Hello, my name is Lindsay, and my interest in my subject, nanomedicine and cancer, comes from a general interest in the research of curing cancer. My contribution to this project was my own research on my topic.
My name is Raveen Karnik. My interest in this topic stems from a fascination with nanotechnology ever since I discovered it, which is why I suggested it to our group. I chose my specific application of nanotechnology with tissue engineering because I was really curious how it would be possible to blend technology and life. My contributions to this project were my research into my own topic as well as editing this video together.
Hi, I'm Natalia. I'm a 16-year-old junior at Sunset High School in Portland, Oregon. I currently take IB Sports Exercise Health Science. For the Group 4 project, I wanted to research more about nanotechnology, see how nanotechnology can affect sports equipment and the sports exercise world.
Our topic was nanotechnology. Nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology is a broad field, so we specifically focused on nanotechnology's applications with people.
Nanomedicine is the application of nanotechnology. In this case, the nanomedicine having to do with cancer is largely in the development phase. However, when it can be used on the public, the nanoparticles will most likely be injected into the body. The dimensions of these nanoparticles are usually smaller than 100 nanometers. There are two ways that the nanoparticles are made, the top-down approach having to do with breaking structures down and the bottom-up approach having to do with building structures up. The top-down approach breaks down large pieces of material to generate the required nanostructures from them. This method is particularly suitable for making interconnected and integrated structures. The bottom-up approach assembles single atoms and molecules into larger nanostructures. This creates identical structures. Nanomedicine having to do with cancer overall is about diagnosing and treating the cancer. There are many different ways of treatment and diagnosis in the development phase, like biomarkers, heat application, drug delivery, and light application. Biomarkers, the indicators produced by tumor cells, would be easier to detect with the injection of nanoparticles. Other nanoparticles could be put into the body to bind to tumors so there can be accurate mapping of lesions. With heat application, nanoparticles can be injected into the tumor where, when activated, they produce heat and destroy cancer cells locally, either by magnetic fields, X-rays, or light. Meanwhile, the encapsulation of existing chemotherapy drugs or genes allows much more localized delivery and reduces the quantity of drugs absorbed by the patient as well as the side effects on healthy tissue.
Tissue engineering is a branch of nanomedicine. Tissue engineering focuses on developing biological substitutes to restore, replace, maintain, or enhance tissue and organ function. In order for this to work, scientists need to create artificial structures on the nanoscale, which can provide a scaffold to which cultivated cells can attach in order to become functioning implantable tissue. These artificially created structures are produced in a variety of different ways, but two of the most common methods are electrospinning and self-assembly. Electrospinning is a method of producing fibers of microscopic widths through the application of electric force to a liquefied polymer. By applying electric force to the liquid becomes charged and begins to elongate due to intermolecular repulsion, eventually turning into a long, thin nanofiber. Intermolecular self-assembly is another common method of producing the nanostructures needed for tissue engineering. The idea here is that molecules are able to adopt a specified shape without any outside help. This is done by programming the desired structure into the shape and functional groups of each of the molecule used, so that eventually their interactions will result in the final shape being formed. When cells are organized into tissues, they do not do this of their own accord. They have an extracellular matrix which contains a variety of different materials that provide a wealth of information and regulate cell growth, shape, migration, and differentiation. When humans need to artificially create tissue, although they can cultivate cells, they need to artificially mimic the physiological properties of the extracellular matrix. Once they have managed to do this, through the methods mentioned earlier, they can combine the new scaffold with cultivated cells and other necessary molecules to create functioning tissue, which can finally be implanted into the body.
So what can carbon nanotubes do in sports exercise technology? Well, generally it can improve performance of our favorite athletes and even yourself. How to make carbon nanotubes? The first method, called arch discharge. Basically, two graphite tubes are put together and then you apply a current into it and then a spark produces and it vaporizes a tip of one of the rods, creating carbon gas that forms a tube. The next method is chemical vapor deposition, or CVD. In CVD, a carbon-based gas and a metal catalyst are put together, it together grows like seeds buried in dirt, basically. How does it work? There are small structures when formed or rolled into a certain way can make carbon nanotubes as strong as steel, as light as a feather, but also smaller than the diameter of a single piece of hair. I'm going to leave some examples here of how nanotubes are starting to be incorporated into sports equipment and clothing, but obviously this won't be all-inclusive, and you never know what new technology they could be making right now. Though there is a lot of research and testing still to be done, it's possible that society will see nanotubes in their sports equipment in the future. With time and innovation and the creation and use of nanotubes, it's possible that technology will become accessible for all.
So here we have a mind map of the whole Group 4 project. So in the center you have our overarching topic of nanotechnology, which connects down to one of our subtopics of nanomedicine, which connects to tissue engineering and cancer treatments, which each have their own little effects. And then at the top you have carbon nanotubes in sports equipment, which it also has its own effects overall, and you can see all the applications and how they all connect here.